Hello, here's another example of the ambiguous case of the law of sines from yesterday's lesson. So here you're being asked to find all solutions for the triangle, round sides to the 10th, angles to the nearest whole degree. If you want to try this one on your own first, you can hit pause now and then check in when you're ready. So first thing I'm going to do here is sketch a picture of what I know. So I'm going to label triangle ABC. Label angle A, side length A, side length B. Then, since this is a side-side angle triangle, I'm going to set up the law of sines by doing this side length over the sine of this angle equals this side length over the sine of this angle, which gives me that. I then solve for angle B. The way you do that is you cross multiply, you then divide by 54, you then do the inverse sign, and that's what you get right there. You can then type that into your calculator, and your calculator will tell you that it's about, I'm going to round to the nearest whole degree, which is 48 degrees. However, when you are doing inverse sine, you have to remember that there's more than one possible answer. Your calculator only gives you the quadrant 1 answer. You need to find the quadrant 2 answer by doing 180 minus the quadrant 1 answer. That's 180 minus your reference angle. So 132 degrees also has a sine of this. So there are two possibilities for angle B, either 48 degrees or 132 degrees. Then you check that 132 and make sure it actually fits in your triangle based on the angle you already know. Make sure it doesn't add up to more than 180 with the angle you already know. And 40 plus 132 is 172, or under 180, so that is a second possibility. At this point, what you then need to do is you need to finish solving each one of these triangles. Since there are two different triangles now, we find the missing parts of each one. So if angle B is 48 degrees, that means angle C would be 92 degrees by subtracting from 180. And then you can set up the law of sines to find side length C over the sine of angle C equals, and then I'm going to use the given here side length and angle of 54 and 40 degrees. I solve for side length C and I get 84. I then do the same steps with this second possibility. If angle B is 132 degrees, then angle C would be 8 degrees. And then to find side length C for this triangle, you set up the law of sines again, and you can see it looks very similar, but we've got a different number here for angle C. You solve it, and you get that side length C is 11.7. So there's another example of the ambiguous case of the law of sines. Please email me with any questions.